Hello, welcome to this new video. So in this video we are going to have a look at the research paper implementation of Model-Agnostic Meta-Learning or MAML. So first let us have a look at the problem statement the paper tries to address. So in traditional machine learning models, if we once train a particular model for a particular task, and if we have to adapt those models to a new task, then traditionally what we do is that we do transfer learning or fine tuning of those model to adapt to the new task. But this is a time consuming process, and also we require a large amount of data for training the new model. So what this research paper proposes is that it proposes a meta-learning whereby we train a model on variety of tasks such that it can solve a new learning task by only using a small number of training samples. This way we can reduce the time we need to train or adapt the particular model to a new task, as well as reduce the time we spend collecting data, as well as the amount of data, since we require is small, we can easily adapt a model to a new task. So some of the key highlights that they have shown in this particular paper is that since this particular approach is used to train a model, so there are no additional parameters that we are adding to a model such as layer. It is just a modification of our traditional training loop in a specific way to update the gradients differently for the previous task as well as the new task separately, thereby allowing the model to adapt to the new task as well as the old task very well. So this is not again limited to any particular architecture of model or any specific types of problem statements such as classification, regression, or reinforcement learning. So in this approach, the parameters of the model are explicitly trained in a small number of gradient steps on the new task, such that it will produce a good generalized performance on the new task rather than overfitting on the new task while it prevents or loses its memory of its previous task. In this, they demonstrate this particular approach by performing a few shot image classification task, and we try to replicate that particular result using our own data set. So in this data set, what they have done is that they have taken the help of some number of people who they have asked to perform certain hand gesture action as shown in the right. So like push, pull, sweep, clap, slide, etc. So when they do this particular action, sensors are attached to their hand and different parts of the body to capture the sensor readings, and these sensor readings are recorded for each person and each hand gestures when they perform. And in total in the training set they have around 200,000 training samples, and for testing purposes we have around 56k samples for testing, and in total there are about 27 classes for this particular data set. Now let us have a look at the data format that we have the particular data in. It is in .dat format, which can be opened in MATLAB and in Python. Now let us have a look at the steps we have taken to implement this particular paper. So first step is data pre-processing. Here what we have done is that we have cleaned this particular sensor data and also normalized the data so that there is no bias involved while training the model. After that we applied feature extraction techniques so that we can extract the spectrogram images from these signal data. Next, we went ahead with the model implementation, where we have implemented two models. One is a normal CNN model and another is a ResNet 50 model. Next, we went ahead with the split. Since this approach does not require explicit training and testing sets, so here we do not require our usual training and testing split. Instead, we split the data set into support and query set. So what the support set has is that it has the core number of tasks that the model has to learn, and the query set will have the new set of tasks the model has to adapt to. So in this way the data set will be split, and here also we can maintain a similar split ratio as we usually do for testing as well as training. Then we move ahead with the evaluation of the models. Now let us have a look at the result. So in our result, we first do the normal training procedure, where first we train the model on the training set, then our support set, then we try to fine tune this particular model onto the query set. In this training scenario, we see that CNN performs with an accuracy of 78% on the training set, and when we adapt it to the query set, it performs with a 76% accuracy. In the case of ResNet, the support performance or accuracy is 86%. In the case of a query set, it is 83%. But as you look at the number of data points or instance use, we see that for support set we have close to 200,000 data instance, and for the query set we have around 56,000 instances. So this clearly shows that the model requires a huge amount of data to be able to adapt to the new query set. Now in the case of MAML approach, where we use the same CNN and the ResNet 50 model and use the same support and query set split, you can see that the CNN performs with an accuracy of 79% for the support set, and the adapted task of query set, it performs a 77.4%, and in the case of ResNet also it performs 89% accurately on the support set and 86% accurately on the query set. And in both the cases, if you compare the data points used, you can see that almost 1/10 of the data which we used for the normal training purposes is only being used. So this really shows that the ML approach helps us train or adapt the model to a new set of tasks easily. So that is it for this particular research paper implementation. So if you have any questions, feel free to contact us at contact@codersarts.com, and also do visit our social handles, and don't forget to like, share and subscribe.